What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 5.6, and we're going to be talking about angle side angle and angle side congruence theorems. These are two popular theorems that we're going to continue to see, and we're going to look at how can we use them all to prove triangle congruence. So here they are. Angle side angle means this. If two angles and the included side of one triangle are congruent to two angles and the included side of a second one, then the two triangles are congruent. This just means, notice how we have angle, side, angle, and then over here, angle, side, angle. So C matches to F, AC matches to DF, and then angle D matches to angle A. It is written as whatever it is in order. So the side is being kind of sandwiched by two angles. That's when you would use angle side angle. Okay. But angle side can still have two matching angles, but the side is not being sandwiched between them. So here we have angle side that matches these two congruent triangles. Okay. So once you can prove that there are two matching angles with a matching side, you may use either one of these theorems. You just have to be specific in which one you use. The ASA means the side has to be sandwiched. The AAS means the side can be not in between the two angles. Okay? So what we're going to do here is we're going to look closely at these following triangles and try to prove them with the given information if they are congruent or not. Okay? So if we look at the first one, we can see that an angle is marked here, which obviously this one matches. And then we also have some sides right here that match. Okay. Now, one thing you don't maybe see written right now is these two angles would also match because they are vertical angles. So this one we can say yes using angle, side. And maybe I should put these vertical angles by having the two rings because I don't know if they match that first one. So angle, side, because I have angle, and then a side on the outside with those. Okay. This one in the middle does show us that we have congruent angles, but there are no matching sides. And I don't know if we can really prove that. So we're going to have to say no because no congruent sides are marked. Okay. The last one, we notice we do see some angles. We have one here and one up here, and then we have these two on the inside. Those are going to be your alternate interior angles. That could be like kind of their relationship. But the tricky part about this one is you don't see any sides being marked. But what you do know is if you think about this triangle being matched up with this triangle, they both share a common side, which means this side has to be equal, right? So when we look at that, if we break them up, let's talk about the pink one. Okay, the pink one looks like this. And before I marked up everything, we had two lines here, one line here, and it's probably going to match. It is going to match that other one because when we take your other triangle, one line here, two lines here, and this one would still be matching. Okay, so notice the side is in between the angles. That would mean we can still use it because we have two matching sides with an included side. This would be angle, side, angle. Okay, so far we have learned a few of these. What I wanted to make sure is that we can kind of see the big overall spectrum, I guess, of this. So we've learned side, angle, side, which just means two sides and the included angle are congruent. We've talked about side, side. All three sides are congruent. This is almost like your cheat sheet for theorems. If you want to pause the video here and screenshot this might help you. Hypotenuse leg can only happen with right triangles. That just means the hypotenuses and one legs are congruent, therefore they are going to be congruent triangles. And today, these are our new ones we're adding on. Angle, side, and then angle, side, angle. Okay? So take a screenshot of this, write the important notes down. When you're ready to go on, let's move on and try some more examples in our notes. So this next one has two triangles, and it says in the diagram AB is perpendicular to AD. So we already see that right triangle or that right angle. We also can see that DE is perpendicular to AD, which produces a right angle as well. And then AC is equal to DC. So what we want to do is be able to prove that ABC is congruent to DEC. So let's maybe just start with our tree diagram of statements and reasons. Okay. Number one is always your given. So we're going to go ahead and take a moment to jot those. Okay. So far we have perpendicular right angles. One thing we want to maybe think about is how can we prove that ABC is congruent to DEC triangle? What I am seeing is we know that we have two matching right angles. So let's go ahead and talk about those. Angle A is matching angle D. And that is just the definition of right triangles, right? So def of right triangles. Boom. We also are already told that AC matches DC, so that's a side. So now I need to find maybe another angle. If you look here, these are vertical angles, aren't they? So, and I can't necessarily, this is angle C is equal to angle C. I'm going to have to write the entire letters. So I would maybe say angle ACB is congruent to angle DCE using vertical angles congruence theorem. So, because I have shown that there are two angles that match and an included side, I can say that triangle ABC is congruent to triangle DEC using angle side angle theorem. Okay. Hopefully that helped your brain just a little bit. Let's maybe see if you can try the next one on your own. Sorry for the sloppy handwriting. All right, here is our final example of the video. See if you can try this one on your own. You're going to go ahead and pause here. Angle S is equal to angle U. It's already marked. And RS is congruent to VU, already marked as well. Prove that RST is congruent to VUT. Okay. Hopefully you've gotten a chance to try it. Let's go ahead and start with our given and our starting out statements just to give us our kind of focus on there. So there's our given statements. I really don't know about any other sides that I can say, but I do know I could prove that this angle is equal to this one using the vertical angles congruence theorem. So my statement 2 could be angle STR is congruent to angle UTV by the vertical angles congruence theorem, or you can say definition of vertical angles. Okay. So right now I'm seeing two angles in a matching side. So that reasoning, I'm going to go ahead and be able to write my final proof. Triangle RST is congruent to triangle VUT by the reason of angle, side. Oops, congruence theorem. Okay, hopefully that helped you just kind of work through those. I know proofs are not anyone's super favorite thing to talk about, but there are ways to think of through them one little step at a time. If this video helped